wonder what happens when you die? It involves a lot of chemistry inside your body.
2 to 6 hours after our friend Annie's death, a process called rigor mortis sets in. This is essentially where her muscles become more permeable to calcium ions.
Calcium ions flow into muscle cell to promote attachment between actin and myosin, causing your muscles to contract.
Rigor mortis can be used to estimate the time of death. Maximum stiffness occurs 12 to 24 hours after death.
During rigor mortis, autolysis takes place, which is the self-digestion of the body's cells. Essentially, the body is digesting its own enzymes. Acid hydrolase includes nucleases, proteases, and sulfases.
DNA is also degraded during autolysis. Autolysis is initiated by the cell's lysosomes releasing digestive enzymes into the cytoplasm. Autolysis can be lessened if the organelle, or the entire body, is stored in ice-cold conditions. Sometimes your family, like Annie's family, wishes to preserve your body in order to hold a memorial service. In this case, Annie's wishes were to be buried. So the embalmist must work with formaldehyde in order to preserve it, which results in another chemical reaction.
Embalming fluid used to preserve the body until funeral, and it contains formaldehyde, methanol, and other solvents.
Formaldehyde is a chemical used for the embalming of bodies, and it's actually a very simple organic structure, only involving carbons, hydrogens, and oxygens. It looks something like this. You've got some simple single bonds between carbon and hydrogen, and a double bond between the carbon and the oxygen.
Embalming fluid denatures protein so that bacteria cannot use it as nutrient source. Formaldehyde fixes tissue or cells by connecting primary amine group in a protein molecule with a nearby nitrogen in other protein or DNA molecule.
Sometimes people, like our friend Casey here, prefer to be cremated rather than buried. In cremation, your body is broken down by intense heat. Cremation involves another chemical reaction between your body and high temperatures.
So what actually happens when you're cremated? As you know, your body is made of 96% of your body is made of oxygen, nitrogen, carbon, and hydrogen. And when you're crematized, all your organic matter is destroyed in the intense heat, but all your liquids escape your body as gases. And all those four, as I mentioned before, oxygen, nitrogen, hydrogen, and carbon, will escape your body as either water, carbon dioxide, or carbon monoxide. There's also another element in your body which is called phosphorus. Phosphorus usually is stored in your bones as calcium phosphate, and in the intensive heat, this calcium phosphate dehydrates and decomposes until forming tricalcium phosphate. As this element, it can endure the intensive heat and turns into ashes basically.
This chemical structure is a type of calcium phosphate and is actually what your bones are made of. During cremation, an oxidation reaction occurs using temperatures that reach 760 degrees Celsius all the way to 1,150 degrees Celsius. Fire this hot diminishes all the tissue in your body. What remains is tricalcium phosphate, shown here. Tricalcium phosphate is actually good for the environment and works well as a fertilizer. Sometimes you don't get to choose where you die and what happens to your body, and you just end up dying in a forest. In this case, your body is left there to rot by itself. In this situation, your body goes through a series of steps called decomposition.
There are a series of steps that involve the breakdown of the body. We already covered the rigor mortis, and the pallor mortis, alveolar mortis, and livor mortis involve the shutdown of the organ, but don't include much chemistry. The final step is decomposition.
There are two parts to decomposition. The first one is called biotic decomposition, which is the breakdown of your body by microorganisms. The second part, shown here, is called abiotic decomposition, which is actually a condensation reaction.